we had two devastating earthquakes in 1999 in Kocaeli province. In our proposal here is we would like to risk assessment for the hospital buildings in the Kocaeli province and to make them ready for a future devastating earthquake in the region.
Involving local communities in flood management will help people to take action in their daily lives and policymakers to make the right choices to achieve transformation change. With the support of CDRI, we will be able to make the work more effective for the policy and in the real community.
This solution could be a sustainable and a feasible alternative for developing infrastructure in the Amazon. This fellowship will enable us to fund the lab-based research, plus being a CDR fellow will give us a better chance of having a global impact. It's exciting to think about the possibilities.
Several types of sustainable urban drainage systems are going to be simulated using a hydraulic model. The focus would be on the time to peak and the peak flow rate. And subject to the results, this study can be upscaled to cover other catchments over the island, thus promoting flood management using nature-based solutions. Thank you.
There's no digital landslide risk map and landslide database for Bhutan, despite the fact Bhutan faces severe landslide during the monsoon season. The development of mobile app will help in uploading and downloading the time series landslide data. The decision makers and individuals can locate their position with its landslide risk zone for construction and decision making purposes.
Through this project, we intend to fill the knowledge and awareness gap in the fragile mountain geographies. CDRI will support us in strengthening resilience and institutionalizing the practice of collaborative research on a global scale.
1. We seek to identify reinforced constructions near the coast, built without a coast and with a seismic code. 2. We seek to contribute to the knowledge the scientific community, contribute to the care of the environment, and propose a low-cost energy dissipator to mitigate the seismic effect.
This tool will allow multiple stakeholders to readily identify appropriate IWRM solutions which will significantly impact the environmental and human health outcomes at school. The CDRI fellowship will enable us to fill in the information gap regarding the existing water management practices at school.
This tool will be the first of its kind to have a single API which will be able to accept data from citizen scientists using multiple verticals such as mobile applications and chatbots, as well as near real-time flood inundation using synthetic aperture radar data. Because this citizen science work involves a lot of public participation, CDRI Fellowship's reach and network will be tremendously helpful in making this project a success. Thank you.
In this regard can assess the status of the critical infrastructure against a real-time cyclone, very much essential at the pre-disaster and post-disaster recovery phases for resident community. The fellowship helps us to apply the CCM in a particular cyclone-prone community and disseminate its results with the policy level to make community more resilient in the future.
I aim to utilize Earth observations and several data fusion machine learning techniques to evaluate spatiotemporal variation of temperatures. This fellowship would help me connect with other researchers working in similar topic for better insights.
Process for food and energy security at a regional scale is crucial and is established further through this particular project. The CDRI fellowship will enable us to identify effective mechanisms for implementation of agrivoltaics through not just policy and finance, but also by considering adaptability at the local scale and urban-rural partnerships.
In the proposed solution, we are trying to develop a model for community level resilience analysis, considering baseline functionality of buildings with critical infrastructure systems. For example, road networks, water distribution systems, electrical power network systems. The resilience will be assessed under the climate-induced cyclonic hazards.
The early warning system is based on the detection of ground vibration and infrasound by means of low-cost and low-energy consumption sensors. With the fellowship, we want to provide two practical tools that can be used in any region affected by debris flows.
Using the insights from our study area, Ganjam district, Odisha, a localized inclusive strategy will be developed to respond and manage disaster, climate change, and future emergencies.
The suggested framework would identify disaster risk areas through public participation. Spatial zonation of wetland areas for future development will be done. And lastly, the framework would build infrastructure resilience through people-centric planning processes. The fellowship would provide opportunity and financial aid to enable impactful and actionable research, which could be further applied to all wetlands at local level.
The design of nature-based solutions, which can be integrated into urban expansion planning to enhance capacity of ecosystem services for water management and sustainable development. Support from the CDRI will facilitate participatory research that builds capacity for socio-economic and environmental resilience to flood-related disasters in Brandon, Manitoba.
Channelization has been the main approach to solving the perennial flooding in the Mamahoma Basin in Ghana, but has not been able to stop the floods or reduce the impact of the recurrent floods. The use of urban green spaces and detention storage has had very little attention, though it has the potential to greatly reduce flood peaks. This research will serve as a basis and evidence for the adoption of this approach in the management of floods in Ghana.